Hello, my name is Phil Birch and welcome to Engineering at Sussex.
Welcome to the School of Engineering and Informatics at the University of Sussex.
Today I'm here to talk about electrical and electronic engineering at Sussex University, which is a bit of a mouthful, so I'm just going to abbreviate it to electronic engineering. First, I thought I really should talk about what electronic engineering actually is and what's involved. This is because some people might think that it's just about designing circuits. And that's part of it, it's an important part, but it's actually quite a small part. It's a much broader subject than that. So engineers are interested really in solving real world problems. Every day you're interacting with real engineered devices and we're trying to make them better. Your car is a good example of what one of those devices may be. Over a third of the cost of the car is the electronics. This includes things like engine sensors, parking systems, braking systems, and even your steering. All of this is there to make your car more fuel efficient and to make it safer. By 2030, it's estimated that the cost of the electronics will increase to 50%. And this is as more automotive self-driving systems come online. So increasingly the car should be considered as an electronic device. So at Sussex, you would learn things like control engineering, electrical drive systems, and even computer vision systems, and these could all be part of a vehicle. Another example is your own home. As you know, it's powered from the national grid. We all know about renewable energy and how it's a very desirable thing. It's not a solved problem. Things like AI-powered smart grids, Internet of Things devices, these can make a huge difference to your electricity consumption, bringing down the overall CO2 emissions in the UK, as well as just making life easier. So when you come here, you'll realise that a large part of your degree is about sustainability and trying to make the world a better place to actually live in. My final example is the mobile phone. It's an ideal example of what electrical and electronic engineering actually entails. It has a power supply, it's got charging circuitry, it's powered by an ARM processor, which is a type of embedded system, and you'll learn how to program these at Sussex. You'll also learn about digital systems and microprocessor designs. Phones have RF communication systems, 4G, Wi-Fi, Bluetooth, and near-field communications. Again, you'll learn how to design, build, and use these as part of your degree. So this is an example of one of our electronics labs. Here we teach digital signal processing. We learn to program one of these. We learn to manipulate sound and manipulate video. It's also used for other subjects such as advanced electronics, and it's also used to teach robotics. And you see there's some equipment in the background over here. If you pick our with robotics options, you'll use these robots, and you'll even get to play with one of these guys. So what do our degrees look like, and how will you actually study? So at Sussex, in the department, we teach mechanical engineering, automotive engineering, and electrical and electronics degrees here. In fact, one of the great things about Sussex is that we're one of the few general engineering departments in the country. This means that you're going to work with mechanical engineers as well as electronic engineers during your degree. This is especially true with some of the projects you do, and this is a good thing because in the real world you don't necessarily have that segregation between mechanical and electronics. You may be able to be working together. So the most common degree is the 3-year BEng degree, but you have the option of taking the integrated master's degree, and that means you will graduate with a MEng degree. You can also do an optional industrial placement year. This is normally after year 2. These are paid placements and they can be anywhere in the world. And we sent students to some big known companies in the past, as well as some small engineering companies. Again, the choice is up to you where you would like to go. When you come to apply, you might find a list of degrees that we have quite intimidating, but to be honest, if you pick the wrong one, it doesn't really matter. You can change your mind once you get here. For example, you can switch from BEng to MEng in year 3, and you can decide to do the placement year in year 2. You can even switch from major subjects in year 1, so if you decided you really want to do mechanical engineering for some reason, well, you could in fact switch to that. So what will it be like when you get here? Well, you'll experience a mixture of different teaching methods. These include lectures, tutorials, workshops, and quite a lot of lab experiments. I'm not going to list all of the subjects here, there are far too many, but why don't you have a look at our website for more details? If you look at the prospectus page, you can really see a lot of detail in there on what all the individual modules entail. So as you progress through your degree, you get the chance to specialise further. In years 3 and 4, you can pick from a number of options. This could be modules like electrical drive systems, computer networks, to radio and optical communications. Year 4 has even more optionality, and you'll share these modules with our MSc students. The 3rd year projects are quite an important part of your degree, and you really get to specialise in those. So in your 3rd year you will choose your own individual project. In the 4th year this will be a group project, and these both give you the chance to really specialise in an area of electronic engineering that you really want to. There are a huge variety of subjects. This year's includes things like smart grids, medical image analysis, AI, Internet of Things, the designing and building of robots. We have communication systems. We've got thermal cameras that are designed for use in agriculture. We've students building weeding robots, medical robots for brain surgery, ball robots. Think of that as sort of a BB-8 type robot, and even food printing robots. Sometimes your project might involve designing electronics. We have projects that use body-worn processors and sensors. One example of this is a pressure sensor designed to perform sports performance analysis. So here this is used by coaches to help players improve their volleyball serves. Other students have designed their own interface systems for integrating components. This is an example of an electric field sensor. The student has designed and built and programmed the processors, and they've built that on their own PCB, and many other projects are purely software. For example, I run projects that use deep learning to identify objects in images as part of an autonomous vehicle. If you're interested in cars, you could be part of one of the 2 Formula student teams that we have here. We have both an electric vehicle and a petrol powered vehicle this year, and we even have a wind powered vehicle which is run as a student society. These all compete in international competitions every year. So what makes Sussex special? Well, we're a research intensive department. We have interests in 5G communications, body-worn sensors, electrical power. We have research on computer vision, medical imaging. We've got jet engines and robots. This means you're going to be taught by the world experts in the field. You'll get a state-of-the-art degree taught by the people at the cutting edge of engineering. And if that doesn't convince you, we're only a few miles from Brighton, We're surrounded by the South Downs National Park, and we're the sunniest campus in the UK. So, thank you for listening. Please get in contact if you've got any questions. I hope to see you in person soon, and this is Formula Student.